Welcome to IFA. I fix everything.
Today's project began as a 1986 Pontiac Fiero that would crank but would not start. A used spark plug is the first method I employ to determine if the problem is ignition related. Disconnect the coil wire from the center of the distributor cap and plug in the spark plug. Rest the spark plug threads against the center terminal. Now attempt to start the car. You can use a camera or a friend to determine if you're getting spark. The camera shows no spark. I have a faulty ignition. The ignition module is under warranty and has caused this issue before. When the screws are loose, lift the distributor cap and rotate it on top of the intake plenum, leaving the spark plug wires intact. The ignition module is held in place with two 7/32 machine screws. A small screwdriver can be inserted into the gap and rotated to release the latch as you pull the connector free. The forward two electrical connectors may be easier to remove after the ignition module has been dismounted. I have temporarily replaced the ignition module. Let's check the results. Notice the coil wire is still disconnected and the ignition is producing a high voltage purple spark. The ignition module has failed 3 times. It's time to troubleshoot the ignition system. The first step is to remove the ignition coil and heat shields to allow easier access to the distributor hold-down bolt. Remove the coil wire and the 2 electrical connectors from the ignition coil. The ignition coil is held in place with 2 hexagonal sheet metal screws. With the coil bolts removed, the heat shield will come out as an assembly. It's important to remove any rust from the heat shield or the coil mounting bracket to ensure a good ground. Your ignition rotor could be facing any direction. Be sure to mark it before removing the distributor. I centered a piece of yellow tape on a vacuum line near the tip of the rotor pin and marked it with a black marker. This will allow easy alignment of the rotor when I install a new distributor. Some may find it's easier to remove the ignition module electrical connectors while it's still bolted in place. For safety reasons, I'm removing the ignition module prior to removing the distributor. Next, remove the hold-down clamping bolt. I chose a flex head ratchet for speed, but even an ordinary wrench would work. The distributor could be removed without removing the coil, but I'm replacing the coil as part of this ignition overhaul. If you're going to rebuild the distributor, mark the housing with a chisel or punch at the hold-down bolt location. I'm going to replace the distributor, so I took a photo showing the location of the corner of the distributor housing in relationship to the valve cover. Notice the subtle rotation of the main shaft as the helical gear disengages from the cam gear. A plastic bag can be used to catch the oil dripping from the distributor as it's removed from the engine. To determine if this distributor can be rebuilt, it needs a thorough cleaning and inspection. I'm using a soap solution to remove any dirt, grease, or grime. With the cap cleaned and the terminals beginning to shine, it's time to remove the cap and inspect the interior. The high voltage arcing has turned the interior terminals to an ashen gray. With the cap removed, it's a good time to point out the alignment groove in the ignition module that helps to seal out moisture. I removed the mating gasket so it wouldn't be lost or damaged during the cleaning process. The electrical connector for the pickup coil can be removed before or after the ignition module is removed. A small screwdriver or scribe can be used to release the latch on the pickup coil electrical connector. The rotor is next. Normally it's a quite easy task, but this one is stuck due to the rust on the center shaft. The rotor fits only one way. This rib slips into a scooped groove on the main shaft. Notice the groove aligns with the rotor pin. The rubber O-ring must be replaced. It's deformed and brittle. Notice the divot in the drive gear. This is for alignment purposes and must be returned to the same position. On this distributor, the plain side is aligned with the scooped groove for the rotor. To prevent the roll pin from being lost, I tapped it most of the way out and then gripped it with a pair of vice grips and rotated it free. The drive gear was also mildly seated and needed to be removed with a drift punch. The cam-driven drive gear operates 2 systems, the distributor main shaft and the oil pump. Notice the hexagonal socket at the bottom of the drive gear. This is coupled to the oil pump drive shaft. Remove the plain washer and the tabbed washer beneath it. Rotate the distributor main shaft and slide it free. The coked oil is adding some resistance. To disengage the field coil retaining clip, lift one side to disengage the tooth, then slide it over center to release the other tooth. Now remove the field coil and the copper shielding washer from the distributor. The copper washer is not supplied with a new field coil. Next, I inspected the main shaft for obvious signs of wear. Now I'm soaking the parts in muriatic acid to remove the corrosion and coked oil. Muriatic acid can make short work of rust and corrosion, but dirt, grease, and grime are impenetrable. Muriatic acid will etch aluminum and dechrome metal parts immediately. Do not allow it to come in contact with tools. This was my first experience using it on brass, and I was quite satisfied with the results. So I decided to test it on the copper sulfated shielding washer. I was very happy with those results also. With the acid bath complete, the acid was returned to the container and the parts were soaked in clear water to neutralize the acid. The corrosion is removed, but the embedded grease still remains. The main shaft still needs mechanical rust removal. This was my first attempt to clean the bushings of the distributor housing. I poured used brake fluid down the oil passages and burnished the bushings with the main shaft. Brake fluid leaves an oily residue. Dawn dishwashing detergent removes the film. To remove the pinning corrosion from the main shaft, I'm using a bench grinder with a wire wheel. It will clean and burnish the shaft without removing excess material. In a short time, I achieve a high gloss finish. Now I turn my attention to the distributor cap and polish the terminals to a high gloss finish. And a quick touch up on the rotor pin. The oil passages had hard baked-on oil deposits. They were unable to be removed, so I soaked the distributor overnight in gasoline. After soaking overnight, the results were disappointing. So I switched to used brake fluid and soaked it overnight in the same jar, hoping for better results. Here's a small sample of the results. The translucent fluid on the left is the used brake fluid. The oily residue on the right is the deposits that have been broken down and flushed free from the distributor main body. I started by cleaning the rusted steel teeth that are used to magnetically trigger the ignition coil module. Then I moved on to the pitted aluminum body. Soon I was able to polish away 4 decades of corrosion and oily buildup. Although a polished finish is not necessary, it certainly looks nice. Corrosion remained in the deep pocket, so I soaked it in muriatic acid for a second round. Now I'm burnishing the shaft in the shopsmith with a wire wheel. To improve the cleaning performance, I have the drill counter-rotating against the shopsmith. I used a series of wire wheels and steel wool to polish any imperfections. My last stage is a cotton buff with polishing compound to give it a glassy, smooth finish. I'm using the main shaft to polish the interior bushings of the distributor housing. I've inverted the main shaft. Now I'm polishing the magnetic induction pickup. I inverted the cap and filled the interior cavity with enough muriatic acid to submerge the pins. Now I'm polishing the pins with a wire wheel mounted to a Dremel tool. I also polished the brass rotor pin. I organized all the parts of the distributor for reassembly. Here's a close-up image of the pickup coil. The pickup coil is mated to the distributor with a pin and a slot. The copper shielding washer is installed next and held in place with a retaining clip. The instructions called for a 15mm socket to secure the retaining clip. I found it necessary to use a small screwdriver to engage the locking teeth. With the pickup coil in place, it's time to install the main shaft. Install the tabbed washer with the teeth facing down, engaged in the oil passages, followed by the plain washer. Reinstall the spline gear and rotate it so the divot side is facing opposite of the scooped groove. I aligned the hole of the drive gear with a drift punch and then inserted the roll pin. I supported the drive gear on the jaw horse as I seated the roll pin. Then I checked the plain washer and the tabbed washer to be sure there was no binding. I liberally coated the heat sink of the ignition module with dielectric grease. The electrical connector can be attached before or after the ignition module is mounted. Seat the module alignment pins and then insert the two 7/32 bolts. With the corrosion removed from the main shaft, the rotor installs quite easily. Tighten the ignition module bolts carefully so you do not strip the threads. The distributor cap is next and uses the same 7/32 socket. It's now time to rotate the distributor shaft to make sure it rotates smoothly without binding or scraping, and check for end play. This distributor was rebuilt for demonstration purposes only and is not going to be reinstalled. I purchased a new distributor with an upgraded magnetic pickup. Prior to installing the distributor, lubricate the O-ring with motor oil and install the mating gasket. As you lower the distributor into the engine block, rotate the main body so the ignition module clears the cooling lines. As the distributor is lowered, the hex socket will engage the oil pump drive shaft, then the spline gear will engage with the camshaft. Install the rotor on the distributor shaft and press firmly to ensure it's fully seated. Recall when the distributor was removed how the helical gear slightly rotated the main shaft. I did a test fit with the rotor set to its original location and fully seated the distributor. Then I raised the distributor, rotated it one tooth, and reinserted the distributor, allowing the distributor helical gear to rotate into its correct position. Now rotate the distributor main body back to its original location. Because I'm using a new distributor and do not have alignment marks, I'm aligning the corner of the distributor to the corner of the valve cover. Install the hold-down clamp and tighten it to seat the distributor. Then release the tension so that it can be rotated to set the timing. Now reconnect the ignition module electrical connectors. Lower the distributor cap and seat the lip into the ignition module alignment groove. Care should be taken while tightening the distributor mount bolts because it has aluminum threads. I temporarily installed the old ignition coil and test started the engine. The engine ran smoothly, so it's time to change the coil and set the timing. The standoff brackets must be removed from the old coil and installed on the new coil. Then connect the electrical connectors and mount the coil to the engine. I left the heat shield bolts loose to allow easier access to the coil mounting hardware. I had removed the EGR control valve vacuum line to allow more clearance. Setting the timing by ear is a baseline way to set the timing. If you've never set timing before, here's a basic understanding of how to set timing. Keep in mind, you can rotate the distributor by hand without fear of getting a shock. You rotate the distributor to the left and right slowly and listen for the engine RPM to increase. You can also look through the rear window of a Fiero and observe the tachometer. If you accidentally stall the car by turning it too far, rotate it slightly back and then restart the engine. When you find a position that the engine seems to run the smoothest and the RPM is where you'd like it, lock the distributor down. The second method I'd like to demonstrate is how to use a vacuum gauge. A vacuum gauge is inexpensive and it's easy to use. A vacuum gauge is connected to the intake manifold vacuum. I found the primary source here. This vacuum line had not been removed in decades. I broke it free with spark plug boot pullers, but still was unable to remove it until I grabbed a glow plug harness tool and popped it free. I added a rubber adapter to the vacuum line and plugged it into the intake manifold. Using a vacuum gauge is quite simple. Rotate the distributor from the left to right until you find the highest steady vacuum, and then lock the distributor at that point. I saved the timing light procedure for last because the tool costs the most, is not as commonly found in shops today, and the procedure takes the longest. However, it gives the most accurate results. To use the timing light, connect the two alligator clamps to the battery terminals, and the inductive clamp wraps around the number 1 spark plug wire like a clothespin. With the engine running and the trigger pulled on the timing light, every time the number 1 cylinder fires, the timing light will flash like a strobe light. This will illuminate a notch in the harmonic balancer that can be read against a timing indicator pointer. The numbers shown in the picture indicate how many degrees before top dead center from 0 to 12 degrees. The strobing light will freeze the image of the notch in the harmonic balancer to align with the timing mark. Rotate the distributor slowly and watch the degrees change on the indicator. Prior to starting the job, I cleaned the timing degree indicator markings with used brake fluid and a small brush. I also located the notch in the harmonic balancer and marked it with chalk for easier illumination. To set the timing on the Fiero, follow the placard underneath the engine compartment lid. It specifies the engine must be at operating temperature with the air conditioner turned off and the transmission in neutral. Be sure to take safety precautions to prevent the car from rolling. Step 1 is to verify there is no check engine light. Step 2 is to ground the diagnostic terminal in the center console. It's the lower two right-hand pins. If you don't have a special tool, a jumper wire or even a paper clip will suffice. Start the engine and the check engine light will flash repeatedly if the diagnostic terminal is properly grounded. If you've not already done so, connect the alligator clips to the positive and negative battery terminals. The Fiero uses the average timing between the number 1 and number 4 cylinder, so we're going to connect the induction clamp to the number 1 cylinder first. The number 1 cylinder is the rear bank of the engine on the passenger side. The timing mark is tucked away down inside this hole. It should read 10 degrees before top dead center. Route the cord safely away from any moving parts of the engine before you begin. Now squeeze the trigger and aim it at the timing indicator and rotate the distributor left to right until the timing mark aligns with the timing indicator at 10 degrees before top dead center. With the number 1 cylinder set, remove the induction clamp and place it on the center plug wire on the front of the motor. That's the number 4 cylinder. Now recheck the timing and make a fine adjustment if necessary. Anytime the engine is exposed to contamination, it's a good idea to change the oil and filter. This is a 1986 Fiero with 200,000 miles, so I decided to add some stiction eliminator to remove the coking from the pistons and the valve train, similar to the coking we saw on the distributor main shaft. I hope you enjoyed this video and learned a few things along the way. If you did, please like and share. Remember, subscribers are always welcome.